Okay, so in section 3.9, we are solving equations with fractions. And I'm just going to kind of continue from a previous video that I was working on. And I just kind of stopped it. I'm having issues with my pen. So I switched programs. So I have 4/7 x minus 3 equals 13. And when you're solving equations, you always want to get the x term by itself first. So the first thing that I'm going to do is add 3 to both sides. So then I still have 4/7 x equals 16. And when you have a number that's by itself, you can make it a fraction by placing it over 1. And then, so 4/7 x equals 16 over 1. We're going to solve by dividing by 4/7, which means we're going to multiply by the reciprocal. So we're going to flip this over. So those cancel out. And then look to see if anything reduces. And let's see. Okay, so 4 goes into 4 one time. 4 goes into 16 4 times. 4 times 7 is 28 over 1, and 28 divided by 1 is 28. So I'll go ahead and work through this one twice, once with keeping the fractions and one with getting rid of the fractions, which is the process that I prefer is the second one. But so in this whole chapter, we've been dealing with fractions, and so we learned how to add and subtract fractions, and we're just going to use that same concept here in solving equations. So in order to get this x term by itself, the first thing I would do would be to subtract 1/3. And so we're going to come over here and subtract 1/3. What you have to remember is when you are adding or subtracting fractions, you have to have a common denominator. So I'm just going to write over here, my common denominator for each of these is 9. So since 9 times 1 is 9, 1 times 1 is 1. 3 times 3 is 9, and 1 times 3 is 3. So remember, we're subtracting. So now that I have a common denominator, I just subtract the numerators. So 1 minus 3 would be a -2, and you keep the 9. So I have a -2/9, and on this side, I still have the 1/7 x. And then to solve, you multiply by 7 over 1. You always start on the side with the variable. So that's x, and then 2 times 7 is 14, and 9 times 1 is 9. So you can work it that way where you keep the fractions. The way that I work through most of these, and I'm not sure, I think Hawks probably also does them this way, would be to clear the fractions before you solve it. And so what we would do on this one is to come up with the common denominator between all 3 fractions. And I'm going to come back over here. So the common denominator between 7, 3, and 9, we can use the prime factorization method that we use for least common multiple. So 7 is prime, I'm going to keep it. 3 is prime. The prime factorization of 9 would be 3 times 3. So the factors that we have here are 3 and 7. The most that 3 appears on any one line is twice, and the most that 7 appears on any one line is once. So 3 times 3 times 7 is 63, because 3 times 3 is 9, and 9 times 7 is 63. So what I'm going to do is I'm going to come up here, and I'm going to multiply each fraction, each term, whether it's a fraction or not. You're going to multiply each term by 63, by your common denominator. And then we're going to come back and divide by the denominator. So 63 divided by 7 is 9. And then you're going to take that answer and multiply it times your numerator. So 9 times 1 is 9x. 63 divided by 3 is 21. 21 times 1 is 21. 63 divided by 9 is 7. 7 times 1 is 7. And then you don't have any fractions left. So you'll solve this like you would any other equation. You got to get the x term by itself, so you're going to subtract 21. So I've got 9x equals, and then 7 minus 21 is a negative 14. And then to solve for x, you divide by 9. So x equals a negative 14 ninths. So you see you get the same answer, just different processes. If you want to keep the fractions, you can. I'm going to go ahead and clear the fractions, just since that is a new process that I want to cover. Oops, I have 1/7 x. We just did that one. Erase. Let's do a different one. So if I have, let's see, 5/8 x plus 3/4 x equals 1/10. So again, I'm looking for a common denominator between 10, 4, and 8, and you might be able to look at it and come up with a common denominator. If you can't, I'm just reminding you, this is from finding the least common multiple. The prime factorization for 10 is 2 times 5, for 4 is 2 times 2, and for 8 is 2 times 2 times 2. So the factors that we have over here on this side are 2 and 5. The most that 2 appears on any one line is 3. The most that 5 appears on any one line is once. So 2 times 2 times 2 times 5, that's 8 times 5, which is 40. So our common denominator is 40, and we're going to multiply each term by 40. So 40 divided by 8 is 5. 5 times 5 is 25x. 40 divided by 4 is 10. 10 times 3 is 30. And I have the x. 40 divided by 10 is 4. 4 times 1 is 4. So 25 plus 30 is 55x equals 4. And then to solve for x, you would divide by 55. So you have x equals 4 over 55. We'll do 1/10 minus, or equals 4/7 x minus 3/10. So when I look at this one, I think that it's going to be easier to solve this one by keeping the fractions, because I recognize that the first thing that I would do would be to add 3/10, and they already have a common denominator. So I'm going to go ahead and do that on this one, since I already have a common denominator. 1/10 plus 3/10 would be 4/10. And then to solve for x, we're going to multiply by 7 over 4. And let's see, the 4 cancels out. So I end up with 7/10 equals x. Now I'll go ahead and work through it the other way, just to show you that it works the same. You get the same answer. So the common denominator between 10 and 7 is going to be 70. And then 70 divided by 10 is 7. So 7 times 1 is 7. 70 divided by 7 is 10. 4 times 10 is 40. And 70 divided by 10 is 7. And 7 times 3 is 21. So then I'm going to go ahead and add 21. So I have 28 equals 40x. we'll divide by 40. So I have 28 over 40. X equals 28 over 40, but we can reduce that. 4 will divide into each of these. 28 divided by 4 is 7, and 40 divided by 4 is 10. So you get the same answer.